Good afternoon, everybody. My name is Cassie Sofing, and I'm a member of the Globe Mission Mosquito team. And today I'm joined by Dr. Rusty Lowe, Dorian Janney, Liz Burke, who are also members of the Globe Mission Mosquito team, and Peder Nelson from Oregon State University. And so we welcome you to storytelling using satellites, learning and teaching about the Earth's interconnections through extreme Earth events.
We're going to begin, as we usually do, by looking at the metrics, which we could not do everything that we're doing if it wasn't for all of you, the Globe community, that are out there and taking measurements and sending data in so that we better understand Earth and Earth systems. Then Liz is going to give us an update on the Mission Mosquito Notebook, which we hope you're getting a chance to use. And our featured presenters today are Rusty and Peder. So next slide, please. So here we're looking at the metrics that are showing us all of the locations where data for the mosquito habitat mapper has been collected and submitted since we began, which was May 30th of 2017. And this goes all the way through October 5th. So you can take a look here, and if you see areas that aren't represented and perhaps you live in one of those areas, please take some data. And if you see areas, for example, where I live that have a lot of representation, pat yourself on the back, because we truly appreciate all of the hard work you're doing to help us reduce the threat of mosquito-transmitted disease. Thank you.
My name is Liz Burke. I'm sorry that I didn't unmute. I was so excited to talk to you. I forgot to unmute. I work out of my home in Kenai, Alaska as part of the mosquito team here. And I've been spending a lot of my time on the science notebook. So we have some of it already in place. You might have already seen that as you've gone onto the website or through other webinars that you've done. But I kind of wanted to bring you up to date. There's a new section that's just been added, and we're continuing to prepare others to enter the queue. So I wanted to give you the heads up and bring you up to speed on everything. This next one, the goal of this next entry in the notebook is to set the hook about doing some research, to get out into the field. What does that feel like? And again, this is geared toward 7, 6, well, maybe even down to 5th grade, 6th grade, maybe up to 8, 9, right in through there. So we want to build some confidence in their ability to get outside and start some of their mosquito research. There actually is a page prior to this. Cassie's got this one up about conducting the habitat survey. There's an introductory page that precedes this, and it basically just gives you the information about how to set up a notebook entry. So we tell them, you gotta have certain things in your notebook so it's consistent, so you have a record that you can count on. And so to have things like, what is the date on which you are doing this research? And because these factors are so important to mosquito research, we want you to record the high and low temperatures of the day that you're out there. We want you to record any precipitation, critical pieces, and Peder's going to build off of all of this, I'm sure, as he goes on. And then we also want you to record any mosquito sightings. And you have to identify the genus and species. You just have to say, yes, I saw some mosquitoes. That's the way to get started, and let them feel comfortable in being able to do that. So once they get to that, then we take them into this how to conduct a mosquito habitat survey. Of course, keeping safety in mind, as we always do, make sure that you are very comfortable and prepared to go out in the field, not only because of the mosquitoes, but because of some viruses that might be out there as well. So we're trying to make sure that they understand how to take care of themselves as a field researcher, but we give them that information, and then we walk them into, here's what you're going to do now to familiarize yourself with mosquito habitats. On the bottom of the page, the one that you see on the left, we give them some tips on how to fill out their data. So again, the date is important. The temperature highs and lows are important. The rain, any precipitation for the day. And again, it's just a yes or no. We don't need them to quantify that. We simply just, was it raining? That's an important piece of information. And it's a scientific observation, so let's use it and build off of it. And then, did you observe any mosquitoes? So trying to get that set up and give them the key for going on to the next page, which is actually the survey data sheet. They can take that, they can print it off, or probably the easiest, print it off and take it outdoors with them. And so again, we're trying to give them examples to acquaint them with possible breeding sites. If you were told to just go outside not knowing, go find some mosquito breeding sites, like, where do I start? So we're trying to give them that starting point. So we've listed, this is actually a product that's been around for a while. We've modified it a bit for this audience, but we've listed examples. Go check out these places. Go check out these containers. Go see if you can find any of these sources so that they get the idea of what they're looking for, and then they fill in the data sheet. We want to show them ways to collect data, how to keep track of your data. And so this is our first step in building some of those skills. And the next entry that's going to come along is kind of going to go back just a little bit to pick up a little bit more biology, just a bit of biology that we still felt was going to be important as they move forward in the mosquito habitat mapper process. So in that new entry that's coming up, we're going to talk a lot about the proboscis, which is the mouth part. And people associate that with feeding, but to the female, it's much different. To the female, it's much more important. And it is so incredibly stealth-like that when they see this and read about this and understand what exactly is happening when that female lands on you and bites you, it's so unbelievably kind of creepy, but really cool. It's just really cool. So we want them to understand what gender bites, why they're biting you, what are they after? And then we want to explain to you their unique talent of being able to suck and spit at the same time. So what is going on? We want to grab that and get them familiar with that. And then the last thing we'll do on the next one is give a little bit of classification. We've got to give them that because now we're going to start using the genera of those key mosquito vectors. And so the Anopheles and the Aedes and the Culex. And so in order, so where does that come from? We have to let them see where that fits in. So we'll give them just a real brief introduction to classification and what those things mean. And after that, boom, we're off and running on some more exciting parts, which I'll bring to you the next time. So thanks a lot. If you have any questions, if you have any suggestions or ideas, we would love to hear from you. So please, you can write to any of us. I am doing a lot of the mosquito notebook stuff. So if you want to send to me, just at Liz, I'll put it in the chat, Liz_Burke at Strategies. I will get back to you and we'll talk and come up with some good ideas. So thank you very much. I am turning it over. Thank you.
Okay, I guess I'm up here. And we're going to be talking today about climate change. And we're going to be talking about the Earth system. And what I wanted to just talk about is that climate change has been discussed probably for the first time in terms of the entire US. Regularly, climate change has been referred to as one of the drivers in the extreme Earth events for this last season. And we've seen straight line winds, which were called derechos. We've had numerous hurricanes, back to back in the Atlantic. And here in the West, we've had lots of wildfires. So this is something which is greatly concerning, but it's also one of the reasons why we do the research we do with respect to looking at Earth system interactions with Globe Observer. Okay, next slide, please. So you may know this, but the Globe Observer is a tool for Earth system scientists to monitor changes in the Earth system. And if you look at our tool with clouds, the tool for mosquitoes, the tool for land cover and trees, those all correspond to land, water, air, and life, which are the four components of the Earth, the four main components of the Earth system. So if we go to the next slide, what we'll see is that this is the sort of the model of the Earth system, and this is our mantra. It's not my mantra. In fact, you can see there, we have Leonardo da Vinci there. He said this like in the 1500s, right? Everything is connected to everything else. So if you have a change in one part of the Earth system, that change is going to propagate changes in all directions. And so if we move on and go to the next slide, we'll talk a little bit more about some of these changes. So here is some, okay, so here we are. Everything is connected to everything else. Let's go to the next slide. Okay, so this is the same view you just saw that Dorian showed you. This is from the Globe Viz. And what I did was yesterday, I just downloaded the mosquito habitat mapper, the land cover, and the tree height data, and I put them all on the same map. And you can see we've got some brilliant coverage in a lot of areas. But if you live in a place where there is a white space here in the US, where we would like to encourage you, like Dorian said, to please contribute to our program. One of the things, though, that's really important, and I really want to stress this, is that Globe Observer is a new program. We've only been around for 3 years. And what this means is we don't have the spatial or temporal density to do a lot of the analysis that we really will hope to do in just a few years. But in the meantime, if you would like to do a robust analysis, you need to have data that's all found in the same place. So there are not too many places on this map where you have a red triangle on top of a brown land cover spot on top of a green tree spot. But this is what we want. So if you are able to take data using the Globe Observer for 2 or more tools every time you take a measurement, you're going to get some great data, and that's going to allow you to sort of get beyond that kind of restriction that we have in terms of data density, and will allow you to do some really robust analyses. And so that is really what I wanted to stress about Earth system, about the Globe Observer. Okay, next one, please. Okay, so the Earth system is actually also our climate system. And, you know, what this means is that if we have an increase in greenhouse gas emissions, we have an increase in our atmospheric temperatures, and that's going to cause more extreme hurricane activity. But it's not just, you know, you can't just draw a line from greenhouse gas emissions to the hurricane season. As you can see, there's lots of interconnections that are involved here. And so that's why we have to look at these things. And I want to say this is also a call out, a special call out to NASA, because if we did not have those sensors up in space that are measuring and giving us quantifications of the fluxes of matter and energy that they're sensing from space across the whole globe, we would not be able to understand these changes in the way that we do. So just keep this picture in your mind, and let's take a look at the next one. And so I have this, if you're interested in looking at this, is a wonderful teaching tool. We have the URL available for you in the slide set, but you can just click on different things so you can see some of these different Earth system pathways. Global warming will cause sea surface temperatures to rise. That will cause the expansion of the ocean. That will cause sea level rise. That will cause coastal flooding, and that will be an impact of hurricanes. Next one. In this interactive, you could also go this way. You could say, well, your greenhouse emissions, it causes changes in the atmosphere of the air that will also increase the temperature on the land, that will cause the glaciers to melt, that will cause sea level rise, that will cause coastal flooding, and that will also cause greater impacts for hurricanes. Okay, next one. We can do the same thing with wildfires. And we know that temperatures are rising and fires are getting worse. And so we're able to actually connect those also using an Earth system analysis. So let's get back to that really cool interactive that I wanted to show you. We tried to embed it, but it did not embed well. So we're just going to give you the URL, and you can use this when you do your own outreach. Next one. So take a look here. Greenhouse emissions create warm temperatures, and that results in a wildfire risk increase, and we have this Western wildfire season. Okay, but let's look at just one or two of these pathways. So the next one, you can see in this interactive, you can look at global warming causes changes in the global air circulation, changes in temperature, and changes in motion. And that will also cause changes in precipitation as well as heat waves. This will cause drought increase and wildfire risk. Another pathway that we could take a look at in this same interactive is the next one, where we can see that greenhouse gas emissions causes changes in air temperature, causes changes in surface temperature. You get surface drying increase, you get drought. Because of this, you also get pine beetle outbreaks. So you're getting then the biosphere involved, as well as the atmosphere, as well as the lithosphere, causing wildfires. So you don't have to remember all these different points, but if you just remember, this is how the Earth system works, connecting air, water, land, and life. Every time we see an outcome on our landscape, that outcome is the result of a very complex series of processes. And our satellites that are monitoring the Earth from space is giving us the data to understand that. Fantastic. Next one, please. Okay, so here's the teaser. What about mosquitoes, right? I just want you to keep in mind that this idea of everything being connected to everything else. And I'm going to just pose to you this challenge. Why don't you think about a little bit as you listen to Peder's talk today, how would a wildfire change the landscape and how would mosquitoes respond? Or how would a hurricane change the landscape and how would mosquitoes respond? How can they take advantage of those changes or do they have to leave? And so we're going to talk I'm going to give you a couple examples of that. And then we're going to turn this over to Peder, who's going to talk about the very extreme conditions that we've had worldwide over the last season. Next one. So here's that map. And so if you're interested, you could actually try and create a diagram like this and fill it in for yourself with the mosquito change in population as the endpoint. Okay, next one. So here are a couple examples of forest fires. I know Rachel was talking about this earlier in our chat. The Carr Fire took place 2 years ago, and there is now strong evidence that there are going to be mosquito problems in this area in California for years to come. There are all these abandoned houses, there are puddles where water has been left behind and it's ponded up. There are people who have had pools. The people are no longer there. Those are wonderful places for mosquitoes to breed. So this has been documented in a number of scientific papers. Another example is with the hurricanes. So moving to the hurricanes now for an example. And this was really something interesting. And actually, Peder pointed this out to me. We were talking, I don't know, about a month ago. But when Hurricane Laura hit Louisiana a month or so ago, I guess 6 weeks ago, there was a big killing of livestock in Louisiana. So what happened is the swarms of mosquitoes were blown in from their natural habitats, and they went into places where farmers were, and they killed off huge herds of cattle. They also killed off, this is on the right, there's a deer farm where people were raising deer meat. And the middle picture is unintelligible, I realize, but it's actually just a solid mass of mosquitoes on the belly of a cow. And so this is another example of how mosquitoes are responding to changes in weather and extreme events. So stay tuned because we are going to see a lot of different changes in mosquitoes that are resulting from climate change. And we will certainly talk about this in a future webinar this year. But we're seeing overall an acceleration of pandemics, all kinds of pandemics resulting from climate change. Those from vector-borne diseases like mosquito vector-borne disease, other kinds of pandemics that we're certainly facing now. There is a climate impact that's resulting from that as well. They change habitat opportunities. They can shift the risks of mosquito-borne diseases. They can even decrease the risk, but right now, mostly it's risk increase. We're seeing that the rising temperatures are now shifting U.S. West Nile virus transmission. And there's a new map that just came out where it shows that climate change is going to be making malaria worse in the very near future. All right. Maybe that's enough about mosquitoes today, because we're now going to be focusing on looking at worldview and looking at extreme Earth events from our NASA satellites. And I'm pleased to have Peder here to talk about that. And Peder, you've got this poll to talk about, so I'm going to let you go. Thanks very much.
Well, thank you so much, Dr. Rusty Lowe, for inviting me to this webinar and allowing me to talk about something that I really care a lot about. And you might have noticed, I just changed my background because I wanted to highlight what I've been experiencing here in Portland, Oregon, in the western part of the United States over the last month. This behind me is a picture of my sky 3 weeks ago. And it was taken with Globe Observer's land cover tool and the cloud tool. I did both of those at the same time because this behind me is phenomenal, right? This is something that is abnormal. I wasn't expecting this to happen in September. And so it surprised me actually that one, we had fires this late in our season and around me, and then the impact that it actually had on not only where the fires were burning, but then all around the country and the world started seeing the effects of smoke like this. So that's kind of what led to this, and wanting to highlight just some of the interesting patterns and shapes and figures and processes that we're able to see through the satellite perspective. And this is really important because it really involves 2 data points. We need a before the event, and then we need an after event. Right? And so everything that we talk about today is really, it requires 2 points in time. And so I want to encourage you as well. We never know when changes might happen. And so being prepared with the data, with the science is a really important part of being prepared for natural hazards and that unpredictability part of the world that we live in. And I want to highlight that there are some lessons and other materials like that that can help you understand this, to take it a little bit further, and to contextualize some of what I'm showing. So part of this is to just get you excited about looking at Earth from space in this way and starting to recognize some of the patterns and shapes that a scientist like me looks at. So I want to start off and really mention that I will be talking about the way we actually measure light. And so it's important to understand what we're measuring and what we're actually showing and what we're able to see as a result of that. And so I will be highlighting parts of light, in particular, the ones that are the visible part of the spectrum, what we see. So why is the sky orange in this case, or why is the sky blue? It gets back to our eyes and what we detect. And so NASA and partners have built satellites and sensors that will measure the light reflection of the visible light. But also importantly, we're able to actually see and measure parts of light that our eyes don't detect. And importantly for plants, this is reflected infrared light. And so as a result of how much red light is absorbed through photosynthesis in an area and how much of that near infrared light is reflected, that ratio tells us something about the health of vegetation. And that tends to be one of the first places we see changes occur, is we see leaves get blown off, we see leaves get combusted into smoke, we see leaves go through their natural senescence process. So I want to highlight that these are important concepts to understand the satellite data, to really make some sense out of what we're looking at. Why would we look at it in that way? Okay. I'm going to take a moment and stop right there. Is there any questions in the chat, Rusty?
No, I just wanted to say a couple things though. Tell them about the trees.
Yes.
Because
okay.
that was what really stunned me.
Right. So I think what you're referring to there is not only, that we're able to detect the type of leaf and the amount of vegetation that's there, but one of the important characteristics about trees is that they grow tall, and there is a vertical piece to them and a vertical structure that we're also able to measure from space. And so we're not just looking at greenness, we're actually able to see how the light gets reflected in an area and how that light changes because the trees have been knocked over and there's less shadow in that area. And so in a sense, we're tracking greenness, how green is that pixel because of vegetation, but we're also tracking shadow. How much shadow is in that area, and how might that change? And so that again, if you only take one measurement, you may not get all of this interesting complexity that really helps us to build that pixel and really understand it. So, a lot of times it takes getting out and seeing these things to really make sense out of them. And so I'm relying on you guys to bring your mental models of the world to what I'm showing here. And hopefully we can reveal some interesting patterns. So with that, I want to take you to one of my favorite viewers. Okay, I want to make the distinction here that primarily we're looking at a viewer. We're not going to be we can't do analysis necessarily inside of here. We can't do a change detection using one image and another image and really highlight that. This primarily relies on your eyes and your computer to make some sense out of these things. And this is a great place to start and figure out, can I actually see what I'm looking for? Did the satellite actually record anything? And then you might go into an analysis software where you can actually use the digital numbers and quantify these differences. Okay, so I want to highlight that difference because there's a lot of viewers out there, and it's important to kind of understand the limitation of some of these tools like that. No, that's perfect. And in fact, Anna, I do want to highlight something because just this last week, one of the things that NASA does is when disasters occur, there is actually an international treaty that facilitates information sharing. And so this is one of the roles that NASA provides to countries around the world to better understand and to track the impacts of natural hazards like this. And I bring that up, Anna, because just earlier this week, the declaration was put into effect to help some of the fires that are happening in Argentina right now. And so this is something that is an important service that NASA helps to provide and is an important part of the mission. So with that, understanding the satellite data might be a first step to understanding what we can actually see, what we want to see, and whether this could actually help you or understand the natural hazards in your area. Okay, so I'll start off with right here. When you go to Worldview, what you're seeing is one of the most recent satellite images that was taken. And so I want to just highlight here that right now we only are seeing half the globe because that's the only half of the globe that has been illuminated today so far. When a satellite is just passing over the North America at this moment, and so we'll eventually see this other piece of it. And so you might see some interesting stripes and interesting patterns inside of here, but just kind of recognize that that's all part of the satellite imagery. I just, looking at this, I see something interesting just kind of popping up right here. And this is something that I do. I kind of look at these satellite images and try to understand the patterns and understand geographically what might be there. I'm seeing this really interesting kind of blue. Is what I would describe it. Kind of, this area that's sort of translucent, and a little bit of a brown color to it, at least on my screen. And so that's one of the pieces of this image interpretation is spending a little bit of time getting to know the colors that are being shown here. And then you'll see these gaps that are there because the Earth is actually round, and here we're trying to flatten it out. And so you can actually see that these clouds are connected in this space. So, you know, sometimes you can actually see through clouds and you can still see the green underneath them. But other times you have clouds that are so thick, you know, they have a lot of vertical structure to them that they actually reflect all of that light. And so this difference between a puffy cloud that has structure to it versus a thin, more wispy type of cloud can actually tell us something about the natural hazards or the way that the atmosphere is moving around the globe. So, you know, with that, we start to notice some interesting shapes and patterns when we zoom out. And I think, you know, one of the things that I'd like to highlight is up here in the northern, up in Europe here, as we zoom in, a key piece here is we're looking at natural colors. And as a result, as I zoom in here, one thing that you should be skeptical, that you should be skeptical about is the white. If something is white, it doesn't always mean that it's a cloud. It can actually mean that it's snow on the ground. And so one of the first things that I'm going to do here is I'm going to pull in another layer that allows us to distinguish a little bit more between features, right? And to do that, we can add layers. And what I would like to add here is another view of our Earth. And like I was mentioning, we can see this in many different ways. And so what I am looking for in here is we can see different band combinations. So these are those different wavelengths that are being measured by the sensors. And so I'm going to actually come in and add in these two bands that allow us to look at some shortwave infrared information. So when I do that, all of a sudden you notice that the colors change. But we still see a similar pattern: snow on the ground, cloud in the sky. So recognize that we have the ability to distinguish colors by measuring different light. Okay, and I'm going to stick with this view of things because it does help us to recognize patterns. And so, you know, right now, as we go across the ocean here and head towards North America, where I want to spend a little bit of time, you can see the end of that image. And so what I'm going to do is time travel. We're going to go back a day. And now we can actually start to see this hurricane that just went over the Yucatan Peninsula and is working its way northward into the Gulf Coast. Okay, and I know this because of the shape of these clouds and sort of the dense colors that are there, right? And so one thing that you can do inside of here is let's just go back in time and we can actually see that hurricane moving away and not quite forming on land yet, right? And so here you can actually go through and watch and see how the course that this hurricane is taking. And that right now is what a lot of people are watching because, you know, as was mentioned earlier, there's already been a hurricane that has gone through this area, right? And so let's go back a month and look at August in this area. And if we go back, we can again see some of the cloud patterns that are out there. And yes.
We got a great question from Sanuka, and I just thought before we move on, she wanted to know why the clouds we see here are blue. Is that because of temperature, or why is it being visualized in this way?
Right. Great question.
Yeah.
In this case, the combination that we saw, it is really heavy. It's a lot of water content. And so what we're seeing there, just like with the snow, it turned that cyan blue color. It's because of the measurements that we're making are revealing a lot of water content. And so in contrast, we can see some areas kind of in here where where the clouds are not quite as dense with water. And so that color piece, the saturation, the intensity of that blue actually helps us to understand how much water is in that area. And so the nice thing is, this is one way that we can measure that water content and try to predict or anticipate how much water might end up being dumped on our landscape as a result of this hurricane. And but luckily, there's other ways of making those same measurements, and so NASA uses all of these different sensors to try to understand the phenomena as it's moving through a system like this. And importantly, we're only getting one image a day of these clouds moving through. And as many of us have experienced, if you're out there, you do see the clouds moving a little bit faster. So it limits our ability to predict a little bit, but just kind of recognize that there's other sensors that kind of help us deal with some of those problems. But so what's interesting is here, August 3rd, we can see this hurricane changing shape off the coast of Florida. And I'm just kind of walking back in time to show you the path that it was taking. Looks like my images are lagging a little bit behind there. Yeah, all right. Oh, yes. So I got to change months. Right, so this is I want to just highlight, what hurricanes look like and how we're able to track some of these different cloud shapes and be able to put together a path of hurricane and what the actual effects of that are. And in fact, inside of here, you can go in and you can find some severe storm information and all kinds of other information to help you make some sense out of that. And so you might be able to find inside of Worldview some other historical data and patterns that might help you to actually connect your ground data to some of these hazards that are happening outside of there. And so, actually connecting what's happening on the African continent and the Sahara to what's happening with these hurricane events is one of the things that we can really do with our natural color images, where we can actually see that plume coming off the coast here and building up. So satellites help us to connect these broad scale patterns that sometimes in our place we can't actually see. And so, you can step back a little bit, and this is really useful to just walk through, and you can do step by step and actually see, this train of weather and the beginnings of hurricanes starting to form because of the dust coming off of the Sahara Desert there. Importantly, as you go out, I'll just kind of highlight some of these really interesting swirls and patterns. And again, this color that we're seeing right here is because of that depth. We can turn these off and go back to our natural color. And here we're seeing that white color we're used to seeing. But pay attention to kind of these spiral shapes that in imagery that usually will indicate that there's something interesting happening. And so, as a result of some of these hurricanes and other things like that, I wanted to now, move us up to the middle of the country, where we don't really have hurricanes coming through. It's landlocked. It's and so the type of weather, the patterns of the wind are a little bit different. And so here I'm going to go forward and notice the interesting patterns of clouds that we see here. I just find this, really interesting, where you can start to see these parallel lines of clouds. right? Those are indicating sort of the way that air is actually moving, and could indicate something happening on the ground. And so what we do know is that August 7th, August 8th, this was all leading to a big wind event that came through this area, and this is, again, as we kind of look at the satellite imagery, it may not be evident that we're actually having 120-mile winds right below us in this area. And so it can be really hard and challenging to see through the clouds and understand what's happening on the ground as a result of the clouds and some of what is happening in the atmosphere and that connection to the land. And so some satellites like this might be able to help us. If we change our colors, sometimes that will enhance and help us to see the ground a little bit better. And as we go in, one of the things that we can also do that will help us when we're looking at vegetation is you can find vegetation inside of here. And so this is, as I mentioned, something that's really important. And so instead of looking at all of these measurements and doing this color image, one of the things that we that scientists produce is a vegetation index. So this tells us how green an area is. And so as a result, we can actually start to see patterns on the landscape that reflect cities. It reflects vegetation patterns. And importantly, we might be able to actually see some of the effects of the wind or other patterns like that. And so, if we zoom in on, say, this area, it's really interesting that we have some of the shapes that we do. And I'm going to roll back a little bit. And interesting. So here, August, as I mentioned, we had this big wind event that came through August 10th, August 11th, August 12th. And we can see some of those effects of what was there, or the differences just a couple days before. And so, there's a subtle green change that you see in some places. And why are we getting those shapes? And why do we go back here? These are some of the patterns that we're able to detect, but we really do need some of that on the ground information to help us to understand, did the satellite actually measure the ground, or did it measure the sky? What actually are the true effects of that event that went through there? And so I'm going to keep this vegetation index on because I want to take you to, again, what created this orange sky behind me that we're experiencing here on the west coast of the United States. And I'm going to zoom in on Oregon because that's where I'm located. And I'm going to start off here in this August timeframe. And I'm zooming into an area that I know we had a fire. And so we're just going to roll through this day by day together and see if we can actually pick up those changes. All right, so August 20th. So you notice we're just getting green, 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 right? And so, we were having a great summer, great summer, great summer, right? It's all nice and green out there. I will highlight that you can actually get these numbers over on the left-hand side to actually quantify how green an area is. But here, if we skip ahead a month, wow, all of a sudden, right, we start to see these changes here in these mountainous areas. And so I want to highlight how that time step that I'm doing here, a 30-day difference, can really accentuate that difference. And what we're seeing is the effects of the fire that we can see from the satellite. So all of a sudden we have less green here, we have less green here, less green here, and less green up here. And that's all what, created this orange haze behind me was all of those burning. And if we go back to our natural color, turn that off. But if we go back to what it looks like to us, notice how using the satellite imagery really highlights these burn scars, these burned areas, right? And that's because we're able to get away from the visible part of the spectrum and see through some of these clouds and actually be able to detect and see the difference in greenness from one time to another time. And so, this has been one of the ways that we're going to be able to look back and understand the intensity or the amount of impact that these fires have had just in Oregon. And the same thing is happening south of us down in California, where they've had over 4 million acres burn up. And so, so that's one way that we're able to actually, measure some of these things. But I wanted to turn off that greenness because we go back to one, notice how dark everything is because that's the shadow. That's the shadow part of what we're looking at. But if I roll back in time, we can actually see all the clouds coming in, right? We just see a lot of cloud vapor that is actually mixed with the smoke. Here we start to actually see what it created this orange sky behind me. And what I want you to notice here is that we can actually see the smoke. Notice how gray and thin that is compared to an actual cloud which is right here, which is coming off the coast. So it's this looking at different areas in different wavelengths allows us to understand these processes. And so, for me, a lot of my time has really started, we'll go back to 2002. This fire right here in Southern Oregon is what got me started in remote sensing, because I had to try to figure out what happened with this fire right here. And it took us another 2-3 years afterwards to really quantify burn severity and how this fire impacted this area. And the story I want to relay to you is that I was one of the last people in an area that had 400-year-old trees there. Those trees grew under the last little ice age. We're now under a completely different climate. And so, yes, we might have trees that grow back, but the trees that were there, that were part of an ancient ecosystem, are no longer there. We have a different climate. We may never get those brewer spruce trees back. And it's that sort of piece of what is going to happen because of these natural hazards that we really want to track. We don't know what's going to happen. And yet you can all of us can help look at the science and try to understand whether these predictions that scientists are making are actually happening. And so that's where Globe Observer and our data that we have available inside of here allows you to make those connections. Everything I showed you, you can actually, a lot of what I showed you, you can go in and you can actually turn on that true color image, just like what we were looking at. And inside of our Globe database, you can walk back in time yourself to start going through and actually seeing what those clouds. Come in here and do things like grab the land cover photos so that you can start to make some sense out of the satellite image and what's on the ground. The mosquito habitat pictures are another great example of connecting what you see here and that hurricane that's coming through and what's actually on the ground. So I hope that some of this has inspired you to just start looking at the satellite images, start trying to understand the patterns. And that will lead you to great questions, because that's where science begins, is just recognizing some interesting patterns and asking, why is that occurring in that location? So hopefully we've got some great questions.
I think so. I loved your story. And I just told people in the chat that the Little Ice Age is a time of cooler conditions that happened during the last 10,000 years, around 1300 to about the mid 1800s. And ever since the 1800s, we've had a natural slight warming effect that's been happening. And what that meant is that trees that start out when it's really cool, those trees are the trees that are adapted to those conditions are different than the ones we have today. And that's why we're going to have different conditions. But I didn't know that story. So thank you so much for sharing that. And what was the name of that fire again that you were talking about?
So the one I talked about that I worked on is called the Biscuit Wildfire.
The Biscuit Wildfire.
And in fact, if you watch the Why Observe land cover video, it's a short 7-minute video, I described that fire in a little bit more detail in my work on it.
This is a good time now. We still have about 10 minutes. If there are any questions, there's one from Sanuka right now, and she says, Peder, do you have any idea what sort of satellite we are using to collect these data? So why don't you talk about what we were looking at today?
Yeah, so what we're looking at is today we were only looking at 2 sensors that were put on 2 different satellites, and they needed to do that to be able to get that global coverage. This is one of these things that scientists have to trade off. Do you want to see detail on Earth, like somebody's individual home or that individual tree, or do you want to be able to see the whole globe, and how often do you want to see that? And so scientists are making these trade-offs. And so what I showed you today is a sensor that is on Terra and the Aqua satellites that are orbiting Earth. And those give us 250 meter pixels on the ground, kind of a big area. And as a result of that, that resolution, we're able to get almost a daily image like this. And like I was highlighting, there's not just one measurement that's being made, like taking an image using your iPhone or a mobile device. In fact, there are at least 12 different we call them bands, or that we're measuring, light that we're measuring, and so we're able to see things in a lot of different ways because of that particular Terra or Aqua satellite. And yes, Lisa, I just saw your question pop up. Yes, so with this, we only get 1 image per day, and usually it occurs at 11:30 in the morning or 1:30 in the afternoon, local time with that. And so that is also a great time to go out and make these observations so that they are coincident with the satellite passover. And so what you'll find is that NASA has over the years produced over 200 different satellites or sensor systems. So part of the challenge that you have is trying to figure out, well, what sensor collected what information and over what area. So one of the challenges, I'll just say this, is that people come up with great projects, but then you find out that the data wasn't good in your area. And so that's one of the challenges that we have is trying to have data everywhere that we actually need it. So I encourage you to explore some of the different NASA satellite missions that are out there, and try to determine what sensor or what data might help you answer your question. They all have, almost every single one of them will be able to measure vegetation. Now, the size of the vegetation that it's picking up, that's the piece that you might need to look a little bit deeper, because I am concerned about this small field, right? That's your study area. Or I'm concerned about my city, or I'm concerned about my state. Right? Each one of those, you might want to actually select a different satellite sensor or data to work with. So that's where we come in handy, and we can help you figure out which one of these might be most useful for your type of analysis with it. And we're glad to talk about that. As you can tell, I can talk about satellites and sensors and data for a really long time. So don't hesitate to let us know sort of what is the time frame that you're wanting to look at, and what is the scale of your question. And if you can answer those two or provide us with those answers, then we can help guide you to the correct data that might be able to help you.
We've got a great question from Lisa. She says, are we able to use aqua remote sensors such as used by Teledyne sensors in taking water temperature, wave height, timing for waves, and weather such as hurricanes and winds? So what role would aqua have with that?
Right. So, so don't get confused here. Terra and Aqua are just the names of the satellites. It could have been named Rock and Moon, for all we know. And so, don't get confused with that one, because the important thing is the sensor that they have on there is the same. And so part of it is when is it cloud free in your area? Unless you actually want to be tracking the clouds. Like a hurricane coming in, if you were tracking wave height, water temperature, some of these variables in the water, you could then look at what did the satellite measure as well at that same location at that same time. And through that, through the two things together, that's where you can come up with a predictive model to say that when we measure vegetation or water from space, this is the color of it, and that usually relates to maybe depth. And so it takes some exploration based off of your ground data to see if the satellite data will provide you with more information over a broader area. Because most cases, you're just making a point measurement with like wave height. The satellites are getting a broader view.
Mm-hmm. And you're talking about MODIS.
Yes, in this case, we're talking about the MODIS sensor. Yeah, and that's was one of these sensors that tried to get over some of these challenges that I was talking about. Not being able to see the right place at the right time, not having daily coverage. And so that's those two satellites were put up in the year 2000 and have been collecting data consistently for nearly 20 years now. So you can really use that to understand those broad patterns. And there's other data that will allow you to get much more fine details. And if you want more information about that, we'll be glad to go into that very site-specific detail.
Well, fantastic. Then I'm going to thank you, Peder, for spending the time today to give us a little bit of insight into the extreme events that we have seen all over the globe. And we do have one more question from Lisa. She says, she's obviously an expert here. She's saying, is it Osiris? Is it Osiris Rex? Will that be supporting these efforts going forward?
So that is a particular type of sensor that will be supporting some of these efforts, but it will be collecting different type of information than the optical satellite data that the MODIS sensor, the moderate resolution sensor, measuring. And so, but this is one of these things. NASA is continually improving what we're able to detect, and they learn from these mistakes or the opportunities that present itself like this to improve each iteration of the sensors. So keep an eye out, and for anybody who's considering careers, NASA will tell you what they're planning 4 or 5 years into the future, and so you can know somebody's building a hyperspectral satellite. Oh, I want to learn how to work with that, and you can plan to know that that satellite will be or a sensor will be going up in a couple years, and you can anticipate and plan for starting to analyze that data. Plan for some of these missions that NASA is letting you know about that they're building or will be building. So it's one of these incredible pieces that a lot of what we learn about other planets and other locations starts on Earth, because we can actually go there. And so that is one of the important pieces that, as everybody is asking and wondering, well, how is NASA exploring other planets? It starts with testing our equipment here on Earth first. And so that's a lot of what we can do. And you guys can all be part of that with exploring the satellite data, using the satellite data, and contributing your globe observation data to our common database that allows us to categorize and make this data available, hopefully for the next 20 years.
I really like that. Thank you so much, Peder. I think that that people that have not yet solidified and ossified in their careers, such as me, I think it'd be very exciting to see what's on the plate and all the sensors that are coming out in 2026 and 2030. Yeah, you can really begin to plan. If you think that's what you want to do, you can start working on it now. So that was great. Thank you so much. And I want to thank everyone in the audience for participating today. We had some wonderful questions, and we look forward to seeing you in our next webinar, which might be just a little bit more mosquito focused. But I want to thank Peder. Thanks again for putting everything in perspective from a very, very challenging season that we have just gone through, and showing us how the Earth system energy is increasing. So thank you very much.